Hello everyone, welcome to SML's YouTube channel. Today I will be discussing how machine learning can be used to predict the initial production or IP for a recompletion opportunity. Let's take a look at a scenario. A reservoir engineer would like to use historical data to predict the amount of initial oil production a recompletion opportunity could produce. In order to make these predictions, a machine learning model should be trained. Once the model is trained, it will be able to detect patterns and trends in the data. Let's look at the data that we will be using to train the model. Our file includes the following features: top X and Y values, which determine the surface location of the well; PNP, which stands for the perforated net pay interval of the wellbore. This is also known as the drained net pay. The other column is the HCP, which is the hydrocarbon pore thickness. The ResD, or resistivity of the interval, this is another variable used in your machine learning model because it is indicative of the amount of water and oil in the well, or water or oil saturation, and therefore is often correlated to the production rates. K here stands for permeability of the interval. Zone index is the zone number that the completion opportunity belongs to. Cumulative water cut, this is the ratio of water produced compared to the volume of the total liquids produced. Next column is cumulative GOR. This is the ratio of the volume of gas that comes out of the solution to the volume of oil at standard conditions. The perf open is the next feature that we are going to use. This indicates the date on which a perforation interval started to produce. Initial pressure value for the interval. DTF, this measures the distance to fault from each opportunity. Phi is the porosity of the interval. At last, we have our target column we would like to predict, which is the initial production value for the recompletion opportunity. Now that we have framed the problem and have examined the data, I will cover the 5 steps required in a machine learning experiment in order to be able to make predictions. We will be using the SAS product SML, which stands for SpeedWise Machine Learning, to demonstrate the 5-step workflow. The first step is to upload the file with the prepared data. After uploading data within the file, we will start machine learning experiment. The second step is to select the target column that we would like to make predictions for. Now I can move to the third step, which is data preprocessing. Data preprocessing is an integral step in machine learning, as the quality of data and the useful information that can be derived from it directly affects the ability of our model to learn. Data preprocessing enhances the quality of the data in a series of steps, such as impute missing data, removing, scaling some of the features, and etc. The reason I use SML is because it automatically applies the pre-processing steps for me. Now I'm ready to move to the fourth step, which is to train a model. Similarly, I will use the autopilot mode to train the model. However, there is a manual option for more advanced users. Great! Now my model is trained, and I'm ready for the last part of the experiment, which allows me to access the model and make predictions on the playground page. The playground page includes many different plots that I can use to learn more about my model. The first plot that I will look at is actually the true versus prediction plot. With this plot, I can see the accuracy of the model by examining points lie inside the 20% error band. As you can see in this plot, the points are closer to the gray band, which indicates a high accuracy model. The partial dependency analysis is another helpful plot in seeing the relationship and trends between features and the target column. For example, in this plot, there is a linear relationship. As the HCPT increases, the IP also increases. Finally, I would like to use SML's prediction card to make predictions on the new rows of data. As you can see, I'm choosing to leave the IP field empty. I'm going to upload the file, and now I can see the predictions SML has come up with for each well's IP. Another way I can make predictions on this tool is by manually editing fields. I'm going to go ahead and change the distance to fault value to 0.46. Now I can click predict to see what the new prediction value will be. Well, I hope this use case was helpful. And if you would like to see more use cases of how machine learning can be applied to solve different problems, please subscribe to our channel and leave a comment for us on what you would like for us to solve next. Thank you so much.